Quadratic function y is equal to 2x squared plus 2ax plus a has the minimum point m when x is equal to 2. Solve for the addition of a and m, which are the constants. Before we solve for this question, let's think about the possibilities of vertexes, which defines the minimum or the maximum point as a vertex of the quadratic function. So the types of the vertexes are usually defined by the a, which we usually call it as the leading coefficient. But the reason why we notate it as a, which will going to be the unknown variable, is because the a value change depends on the times. So the first case is a case when the leading coefficient, which we will gonna notate as a, is greater than 0, which means when the leading coefficient is positive, the graph of the quadratic function will go upward. And when the quadratic function's graph goes upward, for example, it will look something like this that keeps going toward upward. That means it will gonna contain a only one point right over here, which will going to be its minimum point in the quadratic function. And it is a case where the a value, which is the leading coefficient, is greater than 0, which means when it is positive. And for the second cases, it's a case where the a, which is a leading coefficient in the quadratic function, is less than 0. It is less than 0, that can mean as the a value is a negative value, the quadratic function's graph will go downward. And this only occurs when the graph of the function is a quadratic function. And when the function's graph goes downward, for example, it will look something like this that keeps going downward and never ends, which means it never intersects in particular points. It will only contain some point right over here, which is a maximum point of its quadratic function. And if you think about the definition of the vertex of the function, so the vertex of this function, the vertex of any function will going to be defined, or its definition is, it is a addition of the number of possibilities of the minimum point and the maximum points, which means the maximum points or the minimum points, we can sum it up as vertex. So the vertex includes these two kinds of number of possibilities in the quadratic function. Also visually prove this statement through our question. And it says our function in this question will going to be y is equal to 2x squared plus 2ax plus a, where these a values, which will going to be the unknown constant, exist. And our leading coefficient in this function will going to be 2. And then 2 is obviously greater than 0, which means our a value, which will going to be our leading coefficient, is positive value. So we can obviously see that this function, which is y is equal to 2x squared plus 2ax plus a, the graph will go upward, since we knew that our 2, which is our a value, is positive value. Of the function will look something like this, that keeps going upward, and this is our y is equal to 2x squared plus 2ax plus a. And we don't have to draw the x and the y-axis, since we knew that only thing that we need to find in this question is our vertex. And they say that our vertex of this function, when you convert it into a coordinate, it will always going to be x comma y. But the question mentioned about the vertex is x coordinate, which will going to be 2. So our x value will going to be 2. So if we figure out the x value, and x value is also going to be our input of our function in another way. That means if we input our value, which will going to be 2 as our x value to our original function, we'll be close to get our y value, which will going to be the output of our function in the function system. About the m value, the y value, which will going to be our minimum point of this function as m. And the reason why I just talked about the minimum point instead of referring it as y value is because whenever there is a minimum point or the maximum point in the quadratic function or any kinds of functions, if there is no suggestion or in the question, we usually call this the y value instead of calling it as minimum or the maximum value. And in this case, our y value will going to be m. So our vertex of this function, which was x comma y, x value will turn into 2 because they mention about the quadratic functions, these functions vertex, when the x value is equal to 2, they have the minimum point of the quadratic function, which will going to be our output of our function. And that means in our quadratic functions that we convert, they will going to be the minimum point right over here. And the x value is equal to 2, which means the x value, if you just keep following to these directions, to the x-axis direction, it will going to be 2. But we need to think about what is the y value, which will going to be the height in the quadratic function. But if we input our value as our x value into 2, we're going to get blocked because we have the unknown variable, which will going to be a. So we need to convert this form. We need to convert it into some specific forms of quadratic function with the given coordinates. The most suitable forms to convert in this way will going to be a vertex form. The reason is because vertex form is a form that is optimized when it comes to solving for this vertex of this function. And the only forms that we can convert in this case will going to be the vertex form since they gave us the x values of our vertex, which will going to be 2. And for the vertex form, its standard vertex form is a times x minus p squared plus q. And if you think about its statements in the vertex form, the a is a leading coefficient, so leading coefficient, which defines the vertex of this function. So we can see that it will going to be the leading coefficient. And if you think about the p value in the vertex form, p value right over here will going to be the x coordinates, so x coordinate of the vertex. So we can simply input p as our x value. And if you think about what it is to be the q value stands for the y coordinate of the vertex. So we can input every single things that we know from here. So it will going to be y is equal to a times x minus 2, since we knew that our p-value, which is the x-coordinate, is 2 because they gave us this information, and we still have plus q. And we can also say the a value, which will going to be the leading coefficient, as 2. So it will going to be y is equal to 2 times x minus 2 squared plus q. So if you write our vertex form down again, it will going to be y is equal to 2, which is the a value. And then inside the parenthesis, we're going to be x minus 2 squared, since we need that 2 is our x coordinate of our vertex form. And we still have plus q, which we can write it in different colors. If we didn't have the x value of our quadratic function's vertex, or if we didn't know how to convert it into our vertex form, we won't be able to solve for this question. But we need to be careful that even though we can write it as q, they gave us that our y value stands for the m in this question, so we can convert q as plus m. Now all you have to do is we need to extend our vertex form into our standard form. So if you think about the definition of the standard form is a form that we put the terms or the variables in the descending order. So for example, standard form will going to be y is equal to 2x squared plus 2ax plus a, where it will going to be a second power term, and then first power term, and then term means it can be either variables, and then lastly there will going to be a constant in the function. So if you think about the second power term, the second power term is it will going to be x squared in this case, with the a value, which will going to be coefficient, which will going to be 2x squared. And for the first power term, it will going to be ax. It will going to be basically x with the coefficient 2a. And for the constant, the definition of constant, the definition of the constant in the quadratic function or any kind of function, that means it stands for the integers with no variables. And also, if you think about the term variables is a term which will going to be the unknown that varies or changes all the time. For example, the example of unknown variables will going to be the x in this case. So the constant means it is just an integer, so where we can just call it as just a number with no variables, which in this case can be I. So this is what the standard form is. And the good thing about the standard form, basically the vertex form was optimized when it comes to solving for the vertex. The standard form is optimized when it comes to solving for the y-intercept. The reason is because our standard form basic term is ax squared plus bx plus c, and that is equal to y. And if you think about the definition of the y-intercept shows if you convert this into coordinate, it will going to be 0, comma y, where the x value is always equal to 0, and the y value exists, but we just notate it as y because it is a variables right over here. So the reason is because we can simply input 0 into our x value, And then we're gonna get a times 0 squared plus b times 0 plus c. And then the x terms, we're gonna simply cancel out because we have our 0 term. And then we're gonna get y is equal to c. So that's why standard form is optimized when it comes to solving for the for the um, for the y-intercepts of the quadratic function. The definition of the constant in the quadratic function or any kind of function, that means it stands for the integers with no variables. And also, if you think about the term variables, variables is a term which will going to be the unknown that varies or changes all the time. For example, the example of unknown variables will going to be the x in this case. So the constant means it is just an integer, so where we can just call it as just a number with no variables, which in this case can be I. So this is what the standard form is. And the good thing about this standard form, basically the vertex form was optimized when it comes to solving for the vertex. The standard form is optimized when it comes to solving for the y-intercept. The reason is because our standard form basic term is ax squared plus bx plus c, and that is equal to y. And if you think about the definition of the y-intercept, y-intercept shows if you convert this into coordinate, it will going to be 0, comma y, where the x value is always equal to 0, and the y value exists, but we just notate it as y because it is a variables right over here. So the reason is because we can simply input 0 into our x value, and then we're gonna get a times 0 squared plus b times 0 plus c. And then the x terms, we're going to simply cancel out because we have our 0 term. And then we're going to get y is equal to c. So that's why standard form is optimized when it comes to solving for the for the y-intercepts of the quadratic function. It into our standard form, we'll still have 2. And if you extend x minus 2 squared, it will going to be x squared minus 4x plus 4. But we still have our y value of our vertex as m. But if you want to extend even more, we can use distribute property, which we will distribute 2 into our every single terms in order to cancel out this parenthesis. And if we finish our calculation, it will going to be 2x squared minus 8x plus 8 plus our y-intercept or the y-coordinate of our quadratic function vertex, which will going to be plus m. And we need to remind ourselves that m is going to be a constant with no variable. So we can compare it with our original function. So our original function that we already solved for this was 2x squared plus 2ax plus a, and that is equal to y. So 2x squared and 2x squared is same. And for negative 8x and then 2ax has some difference. But they should always be equal because since we knew that it is always there are the terms that contains our first degree power of our variable. So we can make our conclusion that negative 8x is same thing with positive 2ax. All you have to do is we can divide it both terms by 2x in order to isolate our a terms. Then we're going to get 2x, and then this will gonna turn into negative 4 is equal to a. So they told us to find the addition of the a and the m. So our a value will going to be negative 4. And we don't have to calculate this. And for the last one, the a will going to be our is our negative 4, which is our constant. So we can convert this into a negative 4 for more our convenience. A negative 4 is a constant, and the a plus m is also a constant. So they will always going to be same, and we're under the truth that these two functions are same. So a plus m is same thing with negative 4. And then in order to isolate our m term, all you have to do is we can subtract 8 to the both side, which we're going to get our answer. M is equal to negative 12. But we are not done yet. So our m value was negative 12. We found the every single term that we wanted to find in this question except for our ultimate goal of our question. And our ultimate goal of this question was a plus m's addition. So if you want to find the addition of the a plus m, it is the same thing with we can input a as negative 4 and the m value as negative 12, and which will just going to be summed up as negative 16. So our answer for this question will going to be negative 16. But if we finish our original function, so when the x value is equal to 2, it has its y value, and our y value was m, which will going to be negative 12. So if you write our vertex down, even though it was not a thing that we would try to find, it will going to be 2, comma, negative 12. And the most important thing when it comes to solving for this question is converting our format, our coordinate, which was 2 comma y. This was only given coordinates, even though it also contained a variable. And then we had to convert this into the vertex form, which we ended up being when we figure out that our vertex form was something right over here. And then we converted it into a standard form, which was same thing with extending it to in order to compare with our original function, which was y is equal to 2x squared plus 2ax plus a under the truth where this function and our function that we extended to our standard form was exactly same. So our m value, which will going to be our y value, y coordinate of our vertex was negative 12, and our x and our a value, which was the variable, was negative 4. And if they wanted to find the addition of these both numbers, we got the answer, which was equal to negative 16.